Hello, this is Alan Elliott, and this is SAS Essentials, Mastering SAS for Data Analytics, 3rd edition. This is Chapter 19, Part 1, Creating Custom Graphs. In this chapter, we'll be able to use SAS to create scatterplots and line graphs using Gplot, also to create charts using PROC GCHART, and to be able to use SAS to create boxplots, box-and-whiskers plots, using PROC BOXPLOT. Also, we'll be looking at how to create basic plots using SGPLOT. As usual, if you'd like to follow along with the examples in this chapter, please download the files from this web location. Let's get started. All right, let's start section 19.1, creating scatter plots and line graphs using PROC Gplot. So PROC Gplot is a basic routine used to obtain several types of graphs in SAS. And this section illustrates how to create scatter plots and line graphs using PROC Gplot. So the abbreviated syntax for this procedure is as follows. And again, it looks very familiar to other procs, but PROC Gplot followed by some options, and then the main statement here would be plot, and then whatever our plot requests are, followed by optional options. Now, it's a good idea to include the following command before we do a PROC Gplot. This resets all the SAS graphics before we begin. So it's G options reset equal all. And the reason that this is handy is because sometimes you create plots that cause SAS to get into a particular mode in creating plots. And if you continue with a new plot, it will remember the old plot settings. So using G options reset equal all returns everything to the normal settings. Moreover, it's a good practice to include a quit statement after the plot to tell SAS that the graph is complete, and that would simply be quit with a semicolon. All right, so let's look at the plot statement. So here we have some code, PROC Gplot, data equal whatever data file, and then we have the plot statement. In this case, we have y variable, and then an asterisk, and we'll call that by or by. So y variable by x variable slash some options. Now the y variable is going to be the vertical axis, and the x variable is going to be the horizontal axis. Let's look at some common options for PROC Gplot. Of course, there's the data equal option, and then there's the annotate option, and this allows you to change the default graphical elements. And we're not going to talk about this in this chapter, but you might want to look it up if that's something that you might want to use. Uniform specifies that the same axes be used in all of the graphs produced in a particular procedure. And then continuing, here are some common statements for PROC Gplot. Plot and plot 2 specifies information about the vertical and horizontal axes in a scatter or line plot, along with statement options that customize the look of the plot. We'll be looking at these statements below, but we're not going to talk about plot 2. Again, there are a lot of options. We can't cover everything, so some options we won't discuss in the chapter, but you can easily look them up online. The bubble and bubble 2 option is similar to the plot statement, and we will take a look at that later on. The axis, footnote, pattern, and title statements are going to be used to enhance graphs. We've seen similar statements like this in the past, but we'll look at them more closely in this chapter. And then the common statements by, format, label, and where. All right, let's take a look at the variables here first. We have the y variable, which defines the left or vertical axis, the x variable, which defines the horizontal axis. So we can either use numeric or character variables. So if we specify plot, and then y variable by x variable equal n, then n indicates which symbol to use for the plots. And if you want to know what symbols there are, you can look at Appendix A. It also requests multiple plots by including more than one variable within parentheses, such as plot, here we have yvar1, yvar2, so those are both y variables, times the x variable. So this statement produces two plots, one that is yvar1 times the x variable, and the other is yvar2 times the x variable. So we could specify the same series of plots using this plot statement here. And a little bit more about the plot statement. Another form of the plot statement allows you to use a third variable that is a grouping or classification variable. For instance, if we say plot y variable by x variable equal group, then the group is some sort of grouping variable. This will cause the points on the plot to be styled differently for each value of the group. For instance, if we have two groups, group 1, for instance, will have one symbol, and group 2 will have another symbol. Options that appear after the plot specification are used to enhance the plot. For example, here we have plot y variable by x variable, and then a slash c-axis equal color. Now we've seen very similar color options before. This one happens to be the color of the axis equal, we could say blue or red or something like that. And that would cause the axes in the plot to be displayed in the particular color. All right, so let's look at this first example. Open up the program file agraph1.sas. And here we see the G option statement. We're going to see this at the beginning of all of these graph examples. And this is going to be a simple scatter plot. So we say Proc Gplot, data equal, and we're using the CARS data set, mysaslab.cars. And in this case, we're going to plot highway miles per gallon by engine size. And then we have a run statement and the quit statement. And we'll see now that this is a simple scatter plot that's created. And notice the vertical axis, or the left axis, is the highway miles per gallon, goes from 10 to 60. And the engine size goes from 1 to 9. And so this scatter plot provides a little dot or an X for each car with those specified items where you have the engine size and then corresponding to what highway miles per gallon is specified in the data set. Now let's modify the plot a little bit by adding the text or the code that's in red, ctext equal red, and rerun this. And you'll notice that this time the ctext equal red caused the text in the axes to be printed in red. So just an example of how you can control the various colors and sizes of fonts and things like that that are in the plot. So these are some options for how to manage your SAS graph. So these are some common options for Proc Gplot's plot statement, and these are the options that appear after a slash. So we saw in the recent example, c-axis equal color. You can also see frame equal color to specify the frame color, see text equal color to specify the color for the text. And for all of these colors and things like that, you can see Appendix A for the options. Other ones are H-axis or V-axis, specifies information about the horizontal or vertical axis, and we'll see some examples of that coming up. And these are some common options for, again, for the plot statement, again, followed by the slash. So href equal a value list, or vref equal a value list. And again, these allow you to control the numbers that are on the axis. The legend equal specifies a legend definition for use in the plot. No legend suppresses the legend. Symbol, some number, specifies a switch symbol and attributes to use for points. And again, these are specified in Appendix A. No frame suppresses the frame around the plot. And grid causes a grid to be added to the plot. All right, so you have a plot. So what can you do with that? So some convenient things you can do with it. First of all, you can copy the graph. So you can, from the menu, you can select Edit, Copy from the menu bar to copy the graph to a clipboard. And then you can paste it anywhere you want, like Word or PowerPoint. You can export the graph by right-clicking on the graph and then select Save Picture As and select File of Type to export the graph to a standard graphic type like PNG or BIT or some other format. Or you can print the graph. Again, using the right click, you can choose File Print to print a hard copy of the graph. Let's talk about enhancing a Gplot using the symbol statement. So often the purpose of displaying a scatter plot is to illustrate an association between two variables. So the abbreviated syntax for the symbol statement is as follows. So you have symbol and then some number, 1 to 255. And then you optionally can also have colors, appearance, and interpolation options. For example, here's a statement, symbol 1, V equals star. That's going to put a star as the dot. I equal RL, that's an interpolation. In this case, it's linear regression. The color is blue, and the L is the line type, again specified in Appendix A. All right, so here are some common options for the PROC Gplot's symbol statement. Again, we have color equal or C equal, interpolation, and you'll see various interpolations there. RL is linear regression, RQ, quadratic regression, so it's really, I guess, regression cubic. Standard error bars of length K, standard error bars of the mean, join the dots, and specify a high-low interpretation. A line equal N or L equal whatever, so indicates the pattern of the line drawn on the graph. So for instance, line equal 1, and again, see Appendix A. Value equal N or V equal N indicates a symbol used for the plot, like V equals star, and again, Appendix A has those options listed. All right, so let's do an example using some of these options. 19.2, so open up the program file called agraph2.sas, and you'll see here, of course, it begins with the G options, reset all. And then you have the PROC Gplot. We're using the CARS data set. And we're going to plot highway miles per gallon by city miles per gallon. And we're going to use the symbol statement to specify some of the options about how this is going to look. So just like in the example we saw before, we're going to cause it to be a star with linear interpretation, linear regression, and the color blue, and the line type equal 2. All right, so, and we've discussed what that is, so I won't go over that again, but there's some more details about what each of those mean. And here we have the resulting plot, and again, you can see it's blue with stars. The line is a dashed line, which is line equal 2, and so we've specified each of those pieces of this scatter plot, so you can make the scatter plot look like you want according to the options provided for you. Now we can also customize axes in a plot, and to change the characteristics of a plot axes, we use the axis statement. So axis N, so we're choosing which axis, and then some options. So N specifies options for a specific axis, such as axis 1, axis 2, and so on. And applying an axis definition to a plot requires the following 2 steps. So first of all, we define the axis using the axis N statement, axis 1 for instance, and then we have to associate that defined axis to a specific axis in the plot in either Gplot or Gchart. So again, let me specify. So you have to define the axis first, and then you have to apply the axis to the chart in the area that you want it to appear. Okay, let's look more closely at using an axis statement, and here's some code to illustrate it. So in this case, remember there's 2 steps. So step 1 is we're going to define the axis, and in this case we're going to make the axis red. The order equal specifies the numbers that are going to appear on the axis. So it's going to go from 0 to 80 by 5. It's going to have a label, as you can see there, using the font Swiss. The offset is 5, which makes it offset a little bit from 0. The width 2 and the height 2. So a little bit larger than what we would normally get by default. Now we're going to apply this axis, which is step 2, within the PROC Gplot statement. So notice here we have plot highway miles per gallon times city miles per gallon. H-axis, horizontal axis is what that means. H-axis equals axis 1. So we're telling SAS, for the horizontal axis, use the axis that I defined and called axis 1. All right, so let's look at some axis names for Gplot and Gchart because they're a little bit different. So you have to know exactly what's going on here. So for Gplot, you have the H-axis and V-axis, where H-axis is horizontal axis, V-axis is the vertical axis. But for G-chart, you have a little bit of different names for them. You have something called M-axis, which applies to the midpoint axis, which is the axis associated with a group or a categorical specification. You have a G-axis, which applies to the group axis. So when you use the group equal statement, we'll see this in an example here. And then you have the R-axis, which applies to the response axis, which is the axis associated with the count, percent, or frequency of what you're plotting. So remember that when you are using these axis statements for Gplot or Gchart, that you're going to name them a little bit differently. All right, now let's look at some common options for PROC GCHART's axis statement. This is part one. So the color statement, we've seen that before. The labels statement, and notice it's in parentheses. In here, it allows you to specify parts of the label's appearance. So here's an example: label equal H equal 4, that's the height. J is justified, so J equals C is center. Color equal blue, and we're giving it the label my axis. And the order equal specifies the order of the numbers on the axis. For example, you could have 1 to 100 by 5, specifies the axis will contain the numbers 1 to 100 with increments of 5. You need to be careful with that, because if it was 0 to 100 by 5, it may be a little different than 1 to 100 by 5. Just experiment to make sure you're getting what you want. And the values equal option specifies the height of the text, among other items. For instance, value equal H equal 4, and you can put several different things within this parentheses, but it specifies various things about the text. And here's some more, part 2. So the width equal thickness specifies the width of the axis. Offset, we've seen that as an example, moves the axis away from the edge by a certain amount. For example, offset 3,4 moves the x-axis 3% horizontally and the y-axis 4% vertically. So this just sometimes makes the plot a little clearer, because if you have dots or points near the intersection, they can get all confused together, and so by offsetting the axis, sometimes it gives you a clearer plot. Major equal controls the major tick marks. You can see an example there. The minor is a similar kind of thing, where you can specify the minor tick marks. Justification type is you can specify left, center, or right. And A specifies a text angle. For example, A equal 90 to place a horizontal axis at a 90-degree angle. Sometimes having them at an angle can save you some space or make it more clearly readable. All right, so let's mention a couple other things about graphics in SAS. For SAS versions 9.3 or later, you actually may need to turn off automatic ODS graphics, which is the default in those versions, for some of the upcoming graph examples to work. So in the newer versions of SAS, when you try to use some of the older PROC Gplot and things like that, some things like color just doesn't work unless you turn off the ODS graphics part. So you can do that by saying ODS graphics off, and then do whatever you're going to do with PROC Gplot or PROC GCHART, and then just turn it back on, ODS graphics on. Or you can say ODS preferences to turn everything back to the default. So let's look at a hands-on example now then. 19.3, so open up the program file agraph2a.sas, and we can see here we're actually defining two different axes, axis 1 and axis 2. Axis 1 is going to be for the city miles per gallon, and we went over what that meant a little bit earlier. Axis 2 is going to be a different color, green, slightly different order, and a label with an angle of 90 degrees, and an offset of 5, and so forth. And so this is going to give us some interesting results when we do this graph. So let's do PROC Gplot, and notice again we're plotting highway miles per gallon by city miles per gallon. We're going to apply the axis 1 to the horizontal axis, H-axis, and we're going to apply axis 2 to the vertical axis, V-axis. And we're also going to ask for a no frame. We're going to use the symbol one, the dot, with a linear regression interpolation, the color purple, and the line type is going to be 2, or line choice. And we get a really weird looking graph, and again, you would certainly, I don't think you'd want to display this graph on anything besides using an illustration of how to do different colors and things. But this gives you a clear indication of how you can control the various colors. Notice on the vertical axis, the 90-degree made the label appear highway miles per gallon in the way it does, so that makes it look a little bit nicer than what the default is. And notice the numbers on the vertical and horizontal axis are different sizes because we specified different things here. So this just gives you an example visually of how you could change some things. Let's change some things actually back. So in axis 1, we're going to change the offset, the width, and the value h equal 1. We're going to change the axis 2 a little bit, and we're going to change the symbol to gray, and so hopefully we're going to get a little bit more a graph that's maybe a little bit more visually appealing. As you can see here, now we've made things, codified things so that everything is in gray, maybe for to inclusion in a journal or something like that. The labels are the same sizes, and everything looks okay. So again, you can experiment with these various options and make the graph come out the way that is visually appealing according to what you're trying to do. Now let's talk about another way to enhance a plot using Gplot, and that is displaying error bars. So to display data by groups with error bars on the graph, we indicate the variability of which would indicate the variability of the data within the group. We use the I equal option in the symbol statement. For example, here we have symbol. We specify an interpolation or I equal, and to employ this option, we use one of these techniques. I equal STD1JT, a mouthful there, produces error bars that are 1 standard deviation, STD1, that's what that means, and that are joined, J, at the means with tops, T, a T-looking top on each bar. You could also put STD2 or 3. Or you could say I equal box T, which is a box plot, again with T tops at each whisker. So let's do an example. So open up the program file graph3, and here we're defining the 2 axes, axis 1 and axis 2. And notice here we're specifying the order of the numbers and the font, etc., and the offset. The symbol statement is where we have the interpolation statement. So here we have Proc Gplot, again highway miles per gallon divided by cylinders. We're applying the 2 axes. And notice here now, symbol 1, I equal, this is the standard deviation, and then with the 1JT option, height equal 1, line equal 1, and the value equal none. So let's take a look at what that looks like. So again, we see now these the symbol 1, I equal STD1JT, ended us giving us this type of graph, and notice the T's on the top and the bottom of the lines, which again is the 1 standard deviation away from the mean at each point. Or if we changed it to symbol 1, I equal box T, then we would get box plots at for each group. There are a number of cylinders. So for 4 cylinders, we can see the range of the highway miles per gallon and so forth. And you can see, as we would expect, as the number of cylinders goes up from 4, 5, 6, and 8, the highway miles per gallon decreases. Interesting, 12, of course, there's not a whole lot of data there, but it seems to go up a little bit. All right, so let's look at the next section, 19.2, creating bar charts and pie charts. So now we're going to look at GChart instead of Gplot. So to produce bar and pie charts, we use SAS GCHART procedure. And again, the syntax is similar to what we've seen before. PROC GCHART, data equal. And then we can ask for what kind of chart we want. Do we want an H bar, an H bar 3D, a V bar, and so forth? Or do we want a pie chart, a pie 3D, a donut chart, and so forth? We'll see some examples of that. So here's a completed example. So PROC GCHART, data equal my data. H bars, we're asking for horizontal bar charts of the value status. We're going to use the discrete option, as we're going to see in a minute why that is important. The outline color is going to be blue, and the width outline is going to be 3. All right, so let's look at then some options. Data is common. We saw that there's various ways to specify the plot. We can specify axes and footnotes just like in PROC GCHART or Gplot, and then the by format label and where are very common. And again, some options for the bar charts. We can color the axis, frame, or text. We can color the outline or the width of the outline. Discrete is an important one that you really need to hone in on, because that is going to come in handy when you have categorical data. And it says to treat numeric values as discrete, rather than SAS trying to come up with its own midpoint for a bar. It's going to say use the categories that are within the data as those midpoints. And the group variable splits bars into groups, as we'll see. A subgroup, similar kind of thing. And then we can specify the width of the bar, and the space specifies the space between the bars. Some common GCHART options. So inside statistic, outside statistic determines where a statistic will be displayed in a chart. So for instance, we can display the mean, sum, percent, and frequency within the chart, either inside or outside, as we're going to see. The type statistic, which statistic do we want? We specify that. The sum variable defines the response variable. When you use the type equal, should be mean or sum. No legend, again, suppresses the chart legend. CLP equal P specifies the confidence interval to be displayed on the bars. For example, CLM equal 95 for 95% confidence interval. And the error bar type specifies either a top error bar, top bars, or both, as we'll see. All right, so let's look at an example here, 19.5. So let's open up the program file agraph4.sas. Notice here we have a simple version of this to begin with. PROC GCHART, we're using the sum data dataset. We're going to have a horizontal bar chart of status, and we're going to use the discrete option. Remember that I said discrete tells SAS that our numeric values for the status variable should be treated as discrete or individual values. So here we have the result there. So we see now that the discrete values for socioeconomic status was 1, 2, 3, 4, 5. So those are the 5 bars that we get. And also notice it gives us some statistics over to the right. The frequency, cumulative frequency, and the percent and cumulative percent. So that's what an H bar looks like, horizontal bar chart. All right, let's make one little change here, and or actually two, and look at how we can, we're going to look at some various options here. So if we change the H bar to a V bar, and also we're going to use width equal 10 just to make the bars a little bit thicker, just to make them clearer, we see that the bar chart has now flipped, and we have the socioeconomic status groups 1, 2, 3, 4, 5 at the bottom. And when we use the V bar option, or the vertical bar chart option, we also lose those statistics. But if this is the way that you can best display your data, then again, it's a good option. Let's make another change back to H bar, and this time we keep the status in discrete, but this time we're going to add a pattern statement. So pattern value equal R1 and color equal green. Now R1, value equal R1 has to do with what kind of pattern is going to appear in the bar, and so we can see this is a crosshatch, and the color is green. Again, you can look in the Appendix A and see what the various patterns would look like, various crosshatch patterns and other kinds of things. So if we run this, then we get basically the same horizontal bar chart we had before, but now we've enhanced it a little bit by coloring the bars with a special green hatching. Here now, I've mentioned the purpose of the discrete statement. So if we change the H-bar status without the slash discrete, I just want to show you what would happen here. So without the discrete statement, the categories are probably not what we would want. So notice here, instead of 1, 2, 3, 4, 5, SAS chooses its own bars to create, which is completely nonsense. And so when we have discrete values in the categories that we're going to use in a bar chart, you really need to use, almost always, you need to use the discrete option. Okay, now let's look at defining some graph patterns. We saw a pattern option earlier, but the pattern statement allows you to change the color and pattern of a bar in a bar chart. So we have the pattern and then some number 1, 2, 3, 4, 5, color and the type of pattern or value of the pattern. So value R1, color green we saw earlier. Another one would be value solid, color light blue or sea light blue. Here are some definitions for these things. So color is equal color, or we could say empty or solid. We can use R1 through I5, which defines those right 45-degree stripes, R1 being the lightest, R5 the heaviest. X1 to X5 are crosshatch patterns, and L1 to L5 are left 45-degree stripes. So let's look at an example. Open up the program file agraph2.sas, and we notice here we define the two axes, but then in the VBAR statement we have VBAR gender, group equal GP, and then M axis equal axis 1, and the regular axis equal axis 2, and we're going to use the pattern value R1 and the color green. And so this is what we get. Again, this is a vertical bar chart, but what we've done now is we've defined, notice, back up just one again, notice the slash group equal GP. So we have gender, but we also have group equal GP, so we actually have two variables we're dealing with here. One is the GP is the intervention group, and we can see that on the bottom, A, B, and C. And then within the intervention group, we're splitting between gender, male and female. So this is a very handy way to display data. If you have two categorical values that you're trying to describe, this allows you to do it all in one graph. And in this case, we then defined the pattern within male and female. Let's go deeper in this. Open up the program file agraph6, and now we're going to add another statement here. So we have VBAR gender group equal group, and then subgroup equal gender. Notice we have gender twice in here, subgroup equal gender. What is that going to allow us to do? What that does is allows us to specify the patterns for each value of gender. So pattern 1 we're going to call R1 in red, and then pattern 2 is going to be blue. And so what that gives us now is the male and female. We've defined colors for them. So again, we've enhanced the graph here by making female red and male blue. And so again, you can enhance it with whatever colors you want here, but I might make it easier for people to see and understand two different groups here and how they relate to each other. Let's do it a little bit different. We could say value equal X4, just to give you an example of what that does. That's the crosshatch pattern, sort of heavy bars, and we can see what that does is it makes the value X4, the female value now is red with a heavy crosshatch pattern. We can also change the VBAR to VBAR 3D, and again we get another kind of graph. The pattern goes away, but we still have the colors, female, male, as you can see here. So if this is the type of graph that would be good for whatever you're trying to get across to a group, then again, this gives you an option. All right, so that's the end of this part of Chapter 19. We're going to continue with Chapter 19 in just a minute, but continue on, and if this tutorial was handy for you, then we appreciate you subscribing to this channel and liking us. So thank you, and we'll see you next time.